Hey, good morning everybody. Welcome to Xamarin University Presents, a desktop developer's guide to mobile with Visual Studio tools for Xamarin. My goal this morning is to encourage each and every one of you to take your desktop skills and turn them into mobile skills with Xamarin. But before we get to that, I'd like to introduce myself. My name is Mark Smith, and I'm a program manager for Microsoft. My job is to direct the technical and business areas of Xamarin University. I'm also a longtime developer, primarily in the desktop world, going all the way back to 16-bit Windows. I made the jump to mobile about 5 years ago when I was asked to simulate a WPF medical application on the iPad to make it easier for sales to carry around and show people. I bid it pretty low, thinking my strong C and C++ background would help me out with learning Objective-C. After a week of research, I was sweating it, thinking I was about to get paid less than minimum wage for this job. Luckily, I stumbled across Xamarin, which was then called MonoTouch, and I was astonished that I could build the app in C#. I ended up reusing about 75% of the code from the existing app, some of it being tweaked, and some of it just carried straight over. It saved me months of time, and we came in under cost. So I'm here today to show you how you can make the same transition, and either bring some of your apps to new platforms, or just start working on a brand new mobile app with Xamarin. I mentioned that I run Xamarin University. You might be wondering exactly what that is. Xamarin University's mission in life is to teach developers how to build amazing native mobile apps with C#, and we've got tons of resources to engage in that mission. When you sign up for Xamarin University, you get live interactive mobile development training led by Xamarin experts offered in all time zones. You get to interact with talented developers who know the platform better than anyone else. We have one-on-one sessions to get your questions answered fast. This lets you schedule time with Xamarin experts to review your app, get advice, remove technical roadblocks, and more. This is a huge benefit for our subscribers because you get to interact with our experts directly in a focused, open session to move your project forward. Live classes are awesome, but sometimes you need the training now and can't wait for a scheduled class. Self-guided learning enables you to get essential Xamarin training, earning course credits toward certification at your own pace. These classes include the same content as live versions and provide on-demand training right when you need it. The best part of our self-guided learning is it's all free. Just register for an account and you can go through all of our on-demand content and try a few of the live classes. Speaking of training, we've got over 80 live and on-demand courses broken into 8 learning tracks with constantly updated classes ranging from beginner to expert. These also include access to exclusive on-demand videos from industry leaders covering the latest mobile topics and challenges from new platform APIs to testing and deploying on physical devices. We have flexible options for subscriptions, including a monthly option starting at $83.25 a month. That's less than $3 a day to get unlimited access to our full course catalog, expert mobile instruction and advice, hands-on help, and more. Finally, you can work through our courses to become a Xamarin certified developer. Our certification program identifies top mobile developers who complete the certification track coursework and demonstrate practical Xamarin mobile development expertise. I'm a big fan of Xamarin University, and I think it has some of the best curriculum and trainers in the industry. If you really want to learn mobile development, then this is the place to do it. It's easy to register or sign up. Just go to university.xamarin.com to check it out. We're going to start with a brief introduction of the tools we use for mobile development with C#. Next, we'll look at a couple of approaches you can take when building your application user interface. Which approach you choose will often depend on what you're familiar with and the goals you have for the application experience. Then we can talk about the transition path, the similarities and differences between a desktop app and a mobile app. Finally, I want to give you some specific things to think about as you jump on the mobile bandwagon. Things that I learned which were very important as I started building mobile apps. We'll end our session with some Q&A, but you can ask questions at any time during this webinar through the chat window. We've got experts available both during and after the session to make sure you get your questions answered. Let's start by laying out our ultimate goal. What we really want is the ability to write applications that can take full advantage of the power, features, and performance of each platform. But Write the code in a common language, or even better, share the code across all these platforms to reduce development time and help keep application features and fixes synchronized across all of our supported devices. And this is where Xamarin comes in. Xamarin is an app development platform that lets you build applications for iOS, Android, and Windows and share the code across all the platforms. This includes Android phones, iPhones, and Windows Mobile, but it also includes other form factors like Windows Desktop, Mac OS, wearables, IoT, Xbox, and even HoloLens. We can share the code we write across all of these platforms and devices with .NET and the Visual Studio tools for Xamarin. With Xamarin, you write your applications in C# using Visual Studio on either Windows or Mac OS. And it's more than just the C# language. You also gain access to the fantastic .NET libraries which provide standard APIs and productivity features, such as Link and the Task Parallel framework. Even better, this also includes many popular third-party libraries which are available through NuGet, such as JSON.NET and the Entity Framework Core. So you can use the same IDE, the same language, and many of the same libraries that you do today. So if you get anything out of this talk, this is the point I want you to remember. If you are a .NET developer using Visual Studio to build applications today, you can use those same skills to build native mobile applications. So let's talk about the first steps when creating a new mobile app with Xamarin. The first thing you have to decide is whether you want to use the native UI or Xamarin Forms. The first approach is to use the native UI controls directly. This approach allows you to easily customize the user experience on a per-app basis and take advantage of all the unique features that the platform offers. Here you write the behavior and business logic of the app in C#, sharing it across all of your supported platforms. And then you build a unique UI definition for each platform using the native controls available on that platform. This can be done in code, but is most often done using a design tool which works with the dedicated language for the platform. For example, on iOS we use storyboards to craft our UI, and on Android we use XML files with a design surface. And on Windows, we'll often use XAML with the blend tool or a design surface for Windows Forms. This allows all of our core logic to be shared, but the UI definition and code that connects to it is unique and must be crafted differently for each platform. The strength of this approach is that it allows us to craft a unique UI experience for each platform. The downside is that we have to replicate the user interface and the experience 3 times. And if our goal is to make the app look exactly the same on each platform, that's more work for us to do and to maintain as the app evolves. The second approach is to use Xamarin Forms. Xamarin Forms abstracts the UI definition to a common set of shared elements, but have it still utilize native platform-specific controls when it runs. This means we can describe our UI once, either in C# or XAML, and reuse that definition across all our supported platforms. That saves us both maintenance and development time. However, it also makes it harder for us to customize the UI on a per-platform basis. Which approach you decide to use often depends on what you want to build and how you see it evolving in the future. Microsoft developers often choose Xamarin Forms initially because, as you'll see, the APIs and the way you construct the application are very familiar. However, if you want to have a different user experience on Android than you do on iOS, then Xamarin Forms can be a bit limited and you'll end up doing a lot more work to get what you want than if you just use the native UI approach to begin with. As we compare these two approaches to what typical Microsoft desktop developers do today, it's helpful to touch on the history of desktop programming using Microsoft technology. Let's start back in the 90s when we pretty much worked with VB or C or C++ and the Win32 APIs. MFC and VB were all the rage back then, and a lot of enterprise apps were built with both of these technologies. Then .NET was introduced and we got Windows Forms, which is a thin managed wrapper over the Win32 API, but included that easy drag and drop approach popularized by VB. In 2006, .NET 3 was released, which included the next generation framework WPF, and its close cousin Silverlight. This was such a radical departure from Windows Forms that it took years for it to mature and for developers to really learn how to use this framework well. Enterprises were slow to adopt this technology, but it's become one of the most popular ways to build desktop apps today. 2011 was the reinvention of the platform with the introduction of WinRT, a brand new set of APIs available to .NET to interact with operating system services. Things shifted around here with XAML becoming a system service and opening up the system to JavaScript and C++ developers. Most importantly, this ushered in a new style of desktop application, sandboxed and full screen using a new design language to formalize how it should look and feel. Fast forward to today, the latest desktop framework is the Universal Windows Platform, or UWP. This is actually not just for desktops, but for all kinds of devices which run Windows 10. It's built on top of the WinRT APIs that were introduced in 2011, but with additional support so that desktop apps built with UWP act more like we expect them to. Since I'm only supposed to talk for an hour, I'm going to limit our comparison to the most modern of the desktop frameworks. This actually makes my job a bit easier because Xamarin.Forms took a lot of design hits from WPF, which makes it similar to most of the Microsoft frameworks introduced after 2006. However, most of what we talk about applies to Windows Forms as well. It's just that the APIs aren't quite as close, and so there'll be more effort involved in reusing code that you have built specifically for a desktop Windows Forms application when moving to a mobile application. So that we have a reference of comparison, let's create a brand new Xamarin project and look at what we get. So let's switch over to Visual Studio, and I'm going to create a new project. And I can do it right here on the start screen. I can search for project templates, and the one that I want is Cross-Platform App Xamarin. You can also use File, New, Project, and then get the same sort of list. This will just jump me right to where I want in the new project dialog, which is Visual C# Cross-Platform. And I'm going to pick Cross-Platform App Xamarin. We also have a library template here as well as a UI test template to create behavioral-driven UI tests for your application. I'm going to call it App 1, and I'm going to put it on the desktop and just click OK. That's going to give me a dialog here where I can choose the type of app I want. Now, I'm on Visual Studio for Windows. On Visual Studio for Mac, the experience is going to look a little different. You'll have the same sort of options here, but the dialogues that you're driven through are going to look different and they're a little more visual. Here, I'm going to create a blank app. There's also a master detail app that gives a bit more boilerplate code included as part of the project. I personally don't like that. I prefer to just start out from scratch with the bare minimum that I can then build up. And then I can pick my UI technology, Xamarin.Forms or native. This is going to decide the type of UI I want to build. And so either I'm going to construct the UI completely through the native UI toolchain, or I'm going to use a shared UI with Xamarin.Forms. Let's go ahead and pick native just so we can see what it looks like. And then I'm going to pick my code sharing strategy. I have two options here, shared project and portable class library. Shared project is basically a source code level sharing where all of the files included in the shared project are actually compiled into each of your applications. Portable class library is a binary sharing technology where it actually generates a DLL that I had a reference to, and that DLL gets included as part of the runtime process. We're about to have a third option, which is .NET Standard. So .NET Standard was just released and it's now available for Visual Studio, but it's not completely supported yet by Xamarin.Forms, and it's also not listed here in the dialog. But you can create .NET Standard assemblies, so you can create a .NET Standard library, and then consume that from all of your different applications as well. It's also not completely supported right now by UWP, and so there are some restrictions there in terms of the types of things that can consume that .NET Standard library. All of that will be fixed very shortly, and you'll be able to just simply use that. It will be the replacement for portable class libraries. And so in fact, if you look at the latest versions of Visual Studio, they're even listing portable class libraries as legacy libraries, and that's because .NET Standard is intended to replace that. I'm going to go ahead and pick portable class library. I tend to use this one. I don't want to get into a debate of whether or not to use shared project or portable class library because everybody has a different opinion about that. Often what I'll do if I'm building a Xamarin.Forms app is I'll use a shared project for all of my UI stuff and then a portable class library for my actual business logic and things like that. And so I'll often actually combine the two within a project, and you can totally do that. Any combination is possible and you can do whatever you like. So you can see here that I am going to create 3 different projects, one of which is a UWP app, and I need to choose the minimum version level that I want to use there. And so I just took the defaults. So let's just real quickly look at the different project types that we get here. The first one I have in my solution is a portable library project. So this is because I picked the PCL option. And this is going to generate a DLL. This particular one supports a couple of different targets here. It's .NET 4.5, ASP.NET Core 1, Windows 8, Windows Phone 8, Windows Phone Silverlight, Android iOS, iOS Classic, and Xamarin Mac. This is what is done by default. You can change that if you'd like to pick different targets. Generally speaking, portable class libraries have a fairly restrictive set of different profiles, and so even if you start unselecting things, it won't necessarily expand the API set. That's what .NET Standard is intended to address. But this is where I'm going to put all of my shared code. So things like my business logic and my actual logic that's going to run the app, so behavioral type logic, and perhaps my data models and my web service code, so things that are going to access web services, maybe even my database code, all of that can actually be thrown here into this portable class library or the shared project, because it can all be shared with my actual platform specific code. The platform specific code is actually located in these other three projects. So we have one for Android that has Android specific stuff. We have one for iOS that has iOS specific stuff. And then we have one for UWP that has UWP specific stuff. So let's start with Android. So the first thing I want you to notice is every single one of these projects actually includes the portable class library as a reference. And so all of the stuff that we pick in the PCL here is actually going to be available to us in each one of these platform specific projects. The reason we have different platform-specific projects is we're going to generate a different binary for each of those platforms. So what runs on Android doesn't run on iOS, and so we need a unique XE or DLL or whatever the project type needs to be to run on that platform. And so that's what these projects are intended to build and create for you. And in fact, because we picked native UI, you'll actually find that the structures that are contained within these projects are very much influenced by the actual platform target itself. So in the case of Android here, I have a class that is a main activity. It derives from a class called activity, which is an Android type. In fact, it's a Java class. And Xamarin's what's allowing that derivation to happen. And then we've got actual usage of APIs here inside of our onCreate override. OnCreate's called when the application is launched. And you can see here we're getting a content view, and so we're getting that actually from our resources here. And so in resources, we have a folder called layout, and it has an XML file in here called main.xml. That corresponds to this main layout here, and that's going to construct a UI for us that has a button in it and a label. And then you can see we're going and retrieving that button here by its ID, and then we're going to wire up a click handler to that button, so that when we run this, we get a button, and as I click it, it's going to actually increment the text of the button itself. And I'm sorry, there's just a button in here. I think we're just changing the text of the button itself. I also have an iOS project here, and in iOS, I've got different files. I have a main entry point that actually is a static void main, so it's a little closer to what you might be used to in the desktop world. This is calling UI application main, which is an iOS API that launches our app, and it points to an app delegate. That's a different class here that you can see, app delegate. This derives from an iOS class called UI application delegate. And this is sort of our application level kind of construct. It's what gets called initially. It's what creates the initial UI. It has the actual window that we're interacting with when we draw things onto the device surface. And it's got some different notifications here as the application goes through different states. And so when we enter the background or when we're activated or we're terminated, we get some overrides there that can get called to tell us what's happening with our app. Now, in iOS, everything typically gets created through a storyboard. And so you can see here we have a main storyboard. And when you have a Mac host that's actually connected to your PC, then you can actually even use a built-in designer in Visual Studio to be able to drag and drop elements into that storyboard. But I can construct my UI using the same sorts of services that I would use if I were building it with, say, Xcode. And then, of course, I have something called a view controller. In iOS, everything that gets created is always done in the model view controller pattern, and so models are data objects. The controller is what actually drives kind of the behavior of the app, and then the view is what's defined in the storyboard. And so this view controller, it actually corresponds to a page in my application. And you can see it's got some overrides here for when we load, and if we've got some memory issues, so we can do things here in our did receive memory warning to maybe release some resources because we're getting low on memory. And then this right here you can see is the same equivalent logic that we had in our Android application, where we've got a button that's defined in our UI. We're wiring up to an event called touch up inside with a delegate handler that will increment some number of clicks and then set the title back onto the button. But the code doesn't look the same as our Android implementation, because the events that get raised by iOS and the methods that change things like the title of the button are going to be different. Because we're using the native UI here, we have to use the native methods as well. But the upside is I can construct any kind of UI that iOS allows here, and I can use every single control that's available to me, even third-party controls that might be written in, say, Objective-C or Swift. I could potentially incorporate into this application. Same for our Android app. I could use third-party things that were developed in Java and then utilize them from within my Xamarin app. So the world is open to me. I have every single API available, every single widget available, right? So that's the advantage of this model. In the same way, I have a UWP app. Now, UWP is a little bit interesting because UWP doesn't actually use Xamarin. In this case, it's just the regular UWP application type that you would create if I did a file new UWP app, right? So there's no Xamarin involved in this. In fact, if you look at the references here, you won't find any reference to any sort of Xamarin stuff. The only reference that we do have is to our portable class library. So again, we're going to share that behavior, share that business logic, share the database code, share the web service code, the sorts of things that are shareable, and then all of the platform-specific stuff where I'm dealing with device-specific features, or I'm trying to talk to the file system, or I'm doing something that's unique to that device, is going to be placed into these other projects. All right, so that's our native UI. Let's try another one, and let's build one for a Xamarin.Forms app. And so I'm again going to go to cross-platform. We'll use app 2 this time, and I'm going to pick Xamarin.Forms, and let's just pick shared project just for fun. And I'm going to go ahead and create app 2. Now, this is going to create a structure that's pretty similar to what we just saw with the native UI. The difference is that we're going to find some additional classes that are actually going to be located in our shared code. And specifically, we're going to find some UI constructs. Because with Xamarin.Forms, I'm going to be able to define my UI in a standardized fashion that's shared across all of those platform-specific projects. You can see here that we're going to get a new Universal Windows project. So we'll just pick, again, the defaults. And then we'll see what kind of got generated here. And so let me kind of collapse some of these up. And notice that our shared project here, it has a different icon here indicating that it's shared. It has two files in it, app.xaml and mainpage.xaml. So we actually describe our UI in XAML. We'll see a little bit more about that in a second. And you can see here that we're creating a content page. A page just represents a single screen, typically defined by content page. It's a specific type of page that has content. The content page can have a single piece of content, so typically we'll have a panel in here, and then that panel will have other children. In this case, we just have a label, welcome to Xamarin.Forms. And then it also has an app class. The app class is a singleton, kind of like other UI technologies that you're probably used to. It derives from application, and it has some overrides here, similar to what we saw with, say, iOS, where I have a start, a sleep, and a resume telling me when the user is actually going back and forth between my app and other apps. And then I've got my 3 platform-specific projects again. And notice again, I now have my app 2 included as part of this. It's a shared project, so it again has a slightly different icon, but it's being included as a reference here. I have some other things in here as well. So notice that I have Xamarin.Forms Core, Xamarin.Forms Platform, and Xamarin.Forms Platform Android, and then Xamarin.Forms XAML. These are the Xamarin.Forms assemblies. And so these are added because we used a Xamarin.Forms project. And then finally, I have, again, mono.android, which is the runtime for Xamarin.android. On my iOS side, I have the same kinds of references. I have app 2, I have Xamarin.Forms Core, Platform, Platform iOS instead of Android, and then Xamarin.Forms XAML. And then I have a reference to Xamarin iOS, which is the runtime for an iOS app. And then notice that we have an app delegate here, but we do not have a storyboard in the iOS app here because my UI is not going to be done through a storyboard. It's going to be done through this main page.xaml, right? Or whatever set of XAML pages that I may have in here. And in the same way, while I do have a main activity in Android, notice that the main activity doesn't actually inflate any sort of UI, and I don't actually have any UI in my layout here. So we do have a tab bar and a toolbar that potentially can get used. Those are just resources that are here, but it doesn't actually have a main.axml like we saw in the native UI. Instead, we're going to initialize Xamarin.Forms and then load our application up from the Xamarin.Forms side. And so it's Xamarin.Forms that's going to define that UI, but I still have a platform-specific project to put platform-specific stuff in. And so, again, I can still use all the features of Android or all the features of iOS or all the features of UWP. So here's my UWP app here. It's just that instead of having a UI defined in each of these projects that's independent and separate, I'm typically going to define it as a shared resource where this one label will then inflate to a bunch of different types on the runtime side that we'll see. And so this is sort of the basics of the Xamarin application solution and the structure that's contained behind it. So let's go back and let's look at sort of some differences that you might see as you kind of build Xamarin apps versus your desktop apps. As I mentioned earlier, I'm going to restrict this comparison to WPF and beyond, and specifically look at Xamarin.Forms since it's the closest. If you decide your app UI is better suited to a native UI approach, that's great. You'll just need to reset your expectations on reusing any UI type code and provide some layer which connects the native UI controls to your behavior and logic. Let's start with the big picture. Xamarin.Forms actually took a lot of design hints from WPF and Silverlight, so much of the features and capabilities that you're used to in that world are also available in Xamarin.Forms. Some of the features are almost identical. For example, data binding, triggers, styles, behaviors in XAML all pretty much work the way you'd expect them to. Some features have API service differences. For example, the application singleton class has different methods and properties available on it, which are more mobile oriented. And then some capabilities are exposed in a different fashion today. Animations are a good example of that. There is no storyboard in Xamarin.Forms. Instead, we build and start animations in code instead of XAML. So let's look at some of the key differences which tend to bite new developers coming from other XAML platforms. So Xamarin.Forms supports using XAML to describe a UI layout. Syntactically, it's identical. Elements create objects and attributes set properties and wire up events. In fact, the XAML parser with Xamarin.Forms is even better than what we had before because it fully conforms to the XAML specification and supports all the cool additions that WPF never got. The difference is in the UI controls you create and the properties that you work with. Here we have two UI screens created with UWP on the left and Xamarin.Forms on the right. Notice that we're creating the same basic UI and both representations here are XAML. The difference lies in the controls used to describe the UI. On UWP, we have a text box and a password box. On Xamarin.Forms, the entry control serves both purposes based on the property value. On UWP, we have a more relaxed content model where buttons have content properties and can have non-textual values. On Xamarin.Forms, we can only have text in our buttons, so we expose a text property. Notice as well that our color properties have different names. Ultimately, when designing UIs with either the native UI or Xamarin.Forms approach, knowing the control set and properties is the key bit of new knowledge that you're going to need to learn. So we'll see the control set again in a second. Another key technology present in Xamarin.Forms is the data binding engine. This allows you to loosely couple a piece of data exposed through a public property on a .NET object to a visual property on a UI control. The rules are identical to other Microsoft implementations. The source object can be anything as long as it's public, and the target must be a specific property type, in this case, a bindable property. In other systems, we call this a dependency property, but the purpose is identical. It's a specific class which works with the binding engine to do its magic. Bindings can be one-way or two-way, and each bindable property decides the default, so it's a good idea to be explicit in your bindings when you set them up, if you aren't sure what that default is. Just like other data binding engines, you can create and apply bindings in code or in XAML. In fact, these two lines of code here could be used in WPF, UWP, or in Xamarin.Forms. There are some differences though. As you saw, we use bindable object and bindable property instead of dependency object and dependency property. Those original names given to the WPF classes were used because they did a lot more than just provide binding support. However, much of that additional feature set was lost as they were re-implemented in Silverlight and then WinRT and UWP. So Xamarin.Forms chose to name them something a little closer to what they actually do. The same thing is true of the data context property. In WPF and UWP, we use this property to assign a default binding source for all of our bindings applied to that element or to a descendant of that element. We have exactly the same feature in Xamarin.Forms, but the property name is binding context. Here you can see the WPF code assigning a view model to the data context, and the same line of code in Xamarin.Forms assigning the view model to a binding context property. Another difference is the binding markup extension. In WPF and UWP, we have an element name property which allows us to bind to other visual elements in the same XAML tree. That support isn't available in Xamarin.Forms. Instead, it includes the X reference feature from the 2009 XAML specification and allows you to just use that with the source property. This is a more standard XAML way to identify another element by name, and so it was the approach that the Xamarin.Forms team decided to take. There are several other differences that we don't have time to cover today. For example, there's no support for compile time bindings with xbind, and other less used features from WPF such as binding validations, multi-bindings, and binding groups are not implemented in Xamarin.Forms. Constructing user interfaces is a big part of building an app, no matter what technology you use. Xamarin.Forms adopts the same basic layout management that you'll find in WPF and UWP. Layout containers or panels are used to organize children based on some defined set of rules. The layout system uses a two-pass measure and arrange algorithm to position elements, and you can use pre-supplied containers for layout, or if necessary, build your own layout containers to apply some custom logic. Since the layout containers are so prevalent in our UI, it's helpful to compare them. Here are the built-in panels from UWP and WPF as compared to Xamarin.Forms. As you can see, there's a lot of overlap between the styles of panels. In some cases, the panel is only available on one platform. For example, Dock Panel and Uniform Grid only exist in WPF, and Relative Panel is only available in UWP, although we have a similar container in Xamarin.Forms. In many cases, the panels work the same way. Stack Panel and Stack Layout, Grid, and Canvas all work the same across the platforms, although there are some subtle differences when you get into the details, particularly when you're not explicit about your layout properties, as the default behaviors tend to be a little different. The important thing here is that the layout behavior is very similar, so if you've used a stack panel on UWP, then stack layout in Xamarin.Forms will feel very natural to you. Finally, keep in mind, if you need a specific layout design, you can always build a custom panel. There's a wrap panel example in the Xamarin.Forms documentation which you can look at for guidance. And Xamarin.Forms is completely open source, so you can always go look at one of the built-in panels to see how they work. The area where things do quickly tend to get tricky is the layout properties themselves. Each panel has unique properties that it uses to control layout characteristics, and each control exposes properties to help position itself within the parent container. In some cases, it's just a name difference. In others, there are differences in behavior depending on what the parent container happens to be. But this table on the screen is a good mapping of the properties, so you can play with them to get exactly the layout that you want. Xamarin.Forms defines its own UI elements that we use to construct our user application. And just like other UI frameworks, Xamarin.Forms has a visual lifecycle for the application. Xamarin.Forms defines each screen as a page, so when you display a screen of data to a user, you're really defining a page object with visual elements that the user can interact with. When the application is launched, it identifies the starting page, referred to as the main page. It creates the main page object and then calls a series of virtual methods and events to notify the app that things are happening. OnStart is called when the page is first loaded. Appearing is raised just before the page is displayed. If the user switches away to another app, the OnSleep override is called, and when that user switches back to our app, OnResume is called. Finally, just before the page is destroyed, it raises the disappearing event. Also, keep in mind that these interception points shown here are part of Xamarin.Forms and therefore common to all supported platforms. If you need more detail, you can also override platform-specific events and virtual methods that are in the platform-specific projects. On each of your content pages, you'll define visual elements or controls that the user interacts with. The controls implement the core functionality of your UI. All of the most common controls are available directly from Xamarin.Forms, as you can see. There's also an active third-party industry that provides specialized controls, and you can create custom controls if you need to. The interesting thing about Xamarin.Forms controls is that most of them are just thin wrappers around the platform-specific control. Unlike other UI abstractions you might have worked with, Xamarin.Forms always generates a fully native UI, just like the one you might have created if you were using the native UI controls directly. Here's an example. If we want to display a piece of static text in our UI, we will create and place a label element on our page. In Xamarin.Forms, that label object is just a model, which at runtime is processed by a renderer that is platform-specific. iOS, Android, and UWP all have unique renderers which take the label definition and then create a real text object that is unique and specific to the platform it's rendering on. So for iOS, we get a UI label added to our view. On Android, we get a text view, and on UWP, we get a text block. The key thing to understand here is that Xamarin.Forms doesn't do the rendering on its own. The visual elements that will be created by your UI definition are the native platform-specific controls that every app running on that device uses. So even though you're using Xamarin.Forms to define a shared UI, the actual UI itself will look and behave like it should because it's fully native. The downside to Xamarin.Forms is that it only includes the most common controls which all the platforms support. So unique controls that are only present on a subset of the supported platforms are generally not available to your Xamarin.Forms application. You can override this limitation very easily, however. Xamarin.Forms allows you to embed native controls directly in your UI. Here you can see we're utilizing an iOS UI segmented control and putting it into a Xamarin.Forms stack layout. The key thing to notice here is the if-def statement which restricts this code to iOS. This approach only works when you're compiling this code directly into each platform-specific project. That means to use this feature, you'll typically want to be using the shared project approach. This will allow you to use the types that are specific to the platform. I'm showing C# code here to make it clear what's happening, but you can also use conditional tags in XAML to do the same thing. As with the code shown here, you would have to have that XAML in a shared project which is compiled directly into each of the platform-specific projects. Now that we've seen some of the API differences and features of Xamarin.Forms, let's look at a couple of examples of porting desktop-style applications to Xamarin. Okay, so back in Visual Studio, let's close this solution that we've created here, and I'm going to open up a couple of other solutions. I've got some pre-built things that I actually already created and that I've worked with, and I have a GitHub repo that you'll see at the end. And there's two different projects here that I want to show you. The first one is a Windows Forms project. So this was a desktop app that I found on GitHub, and I asked the author if I could use his project as an example. And what he does here is, let me just run it so you can see it. It's a Craigslist scraper application. And so you can pick a city that you happen to live in. I'm in Dallas, and you can search for things like Teslas, and it will actually go through and hit a Craigslist endpoint and then scrape all the data off of it and display things. And if you double click on one, I could just double click and it will open up a web browser and then actually display that particular entry from Craigslist. So it'll just open it up for me from the Dallas Craigslist. Now, in the GitHub notes, you'll find the actual link to the original repo. The very first thing that I did as I decided to port this application is I went ahead and updated it for the latest revision of .NET. And I went ahead and upgraded it to use like async await and things like that. And I made sure it all continued to run properly here in this project. Then I went ahead and copied that project and I created a new version of it. What I did as a starting point, once I'd upgraded it to the latest version of .NET, is I went ahead and took all of the portable bits of it, things that I knew I could share, and I moved it into a portable class library. And so just as an example, I moved the definition for a single item into a portable class library. And so you can see here is the item. It has a link and a price and a date and location and time. And I also moved the logic that was going to do the screen scraping, or at least the XML parsing and such that came from the API. And I moved that into a static class. And so here you can see is a search method with a city and a search term. All of this code was originally part of the actual Windows Forms app. And I then updated the Windows Forms app to ensure that it continued to run. So you can see here it is right here. And I still have my same form. Right? So the form is still there. And the logic for the form is all still present. The difference is that instead of having all the logic bound into the form itself, I went ahead and used my new version of the API, and I tested it and made sure it all continued to work. So you can see here I can go back to Dallas and I can search for cars, and again I get my list, and I can still double click on a car and it opens up a web browser, and you can see that I get my car there. Then I went ahead and added a new project into this, and I added a Xamarin.Forms app, and that created for me these projects right here. So you can see I have a portable class library, I have my Android, I have my iOS, and I have my UWP. In my portable class library, I defined a version of this page to represent this app in a mobile form. So I had to redefine the UI because clearly I can't share Windows Forms definitions. And you can see here that I went ahead and created a search bar and a picker to list the cities, and then I have a list view here that when I tap an item, it does something. And then I created a data template for the list view to actually represent the car, or rather the Craigslist entry itself. And I started with just a regular text cell, so just a regular textual representation binding to the same thing that the Forms app was using. So if we look at the Forms app, just as an example here, you can see its data source is coming from those search terms, and so it comes back with a list of items. And then it's using display member of value, which is just a two-string representation of it. I did the same thing here and just bound to that same value property and verified that it worked, and then kind of extended it to show things in a little bit different fashion. So let's actually run one of these. Let's go ahead and run the Android version. So I'm going to set this as my startup and then go ahead and run this in the Android emulator. That's going to take a second because it has to build this application, and then it has to launch the emulator, but it'll bring the emulator up, and then we can actually see our application run. So now that my emulator's up, I can actually pick my city. And so again, let's just pick Dallas, and I can type in my search term here. Let's do our Tesla again. And then notice that it runs, and I'm going to get my actual results here. And this is where it's displaying me my data template. And so just like before, if I tap on one, I'm actually launching the web browser right here on the device, and I'm actually able to see it right here, the particular entry from Craigslist. And I can go back and then go and pick a different one and see what that one looks like. And so this is the same exact app using all the same code behaviorally that the Windows Forms one did, with a different UI here. Now I can do the same thing for iOS. And so if we switch over to the iOS app and set this as our startup, you have to have a Mac host for this. But you can see up here I've got my Xamarin Mac agent, and it's connected to my MacBook Pro in the corner. And once it's there, I can actually see all the emulators and simulators, as well as any devices that I have connected. And I can tap the button and it will build, go ahead and create the package on the Mac, and then run it on the Mac. And because I'm running the Enterprise Edition of Visual Studio, it can actually remote the simulator from the Mac back here to my Windows machine, so I can actually see and interact with it right here in Windows. And you're going to see I get essentially the same UI. I'm going to have a search bar and a picker, and then a list view below it. So we're sharing that UI definition. That's the benefit of Xamarin Forms. But notice that it doesn't look the same because I'm using an iOS search bar here. So let's pick Dallas again. And then let's go ahead and type in our Tesla. And then you can see that I get all my Tesla information here, and I can pick one, tap on it, and it opens up the web browser just like we saw on Android. Although interestingly enough, it's not displaying the, oh, there it goes, Dallas Craigslist. So here's one for 65,000. Go back, And let's try this last one, 52,000. Oh, that one's pretty nice, red one. So you can see that it actually runs right here inside the simulator. The last application style I have here is the UWP app. And this one's actually quite interesting because this Xamarin port allowed me to actually create a more modern version of the desktop app. So notice I can run this right here on my local machine. And notice it comes up here. I have my search Craigslist. And again, I have my drop down here. I can pick my city. I can type in whatever I'm searching for, and then it will come back with my data. Now, I changed this so that notice on UWP, we don't put a border around it like we did on iOS and Android. So you do have the ability to style and theme the app based upon the operating system it happens to be running on. And so let's pick Lincoln Town Car. And again, it's just going to open up a browser and display the Lincoln Town Car. But this is cool because I'm actually able to create a desktop representation of this with UWP and reuse all the code that we'd already built for the Windows Forms app. So it gives me an immediate upgrade path to the latest sort of edition of the desktop APIs while allowing me to share all that code. And I've got a shared definition here for the UI itself. So that's a Windows Forms app. Let's try another app. I've got one other example here that I want to show you. And I'm going to back up here and let's go into vacation spots. And again, I'm going to open up the original. This was a WPF app, and this app here uses MVVM to be able to structure things. And so let me just run it to show you what it does. The idea was to kind of demonstrate data binding capabilities and things like that, and it was kind of a vacation planner application. So you can see here that I can select different places in the world that I'd like to go to. Dominican Republic, Maui, Cancun. I can scroll down and see there's places in Thailand and Australia, so maybe I'd like to go to Australia. And it gives me some information about it that I might want to know about this particular vacation. You can see it's all colors and images, kind of the 2009 look of a desktop app with WPF where you kind of went wild. So again, just like before, the very first thing that I did with this was I started to break it out into a common set of code that could be shared, and then the visual representation, which was WPF. And so I created a vacation spots common. This has all of my view models, and notice it has all my data, and in fact it even has the base view model implementation here, as well as the delegate command implementation here that we're sharing with the WPF application. So all of this got moved out of the WPF app and moved into a common portable assembly here. Then I created a Xamarin.Forms app, which gave me the portable UI definition. So again, I have a main page.xaml, I have my app.xaml, I have an Android implementation, an iOS, and a UWP. Now, the cool thing about this is I decided to change the UI. That UI that we had for WPF, oh, and by the way, I still have the WPF app. Again, the first thing that I did was to ensure that the WPF app continued to run the way it was supposed to. So I separated out all that code and then made sure that the WPF app continued to look correct when it ran here. So you can see that I still have all of my data here and it's all still running the way I expect it to. But then I started out with my mobile apps. And let me just start with the UWP app here. So I'm going to set this as my startup. And I decided that that UI that we created in the desktop side really wasn't appropriate for a mobile app, right? A list with images, we could totally do that. We've got a master detail view. We could have a list view on one side, and then as you select things in list view, have your detail view change with images and kind of details about it. But I thought that's really not mobile centric. That's not really what a mobile app normally would look like. And so instead what I used was called a carousel view. A carousel view lets me sort of swipe between different entries. And so my app is up now, and you can see here I've got my Dominican Republic, and I can actually click the little buttons here to swipe between the images, but they're nice and big and pretty. And my actual details here is just in a box that kind of goes up and down based upon me tapping this little icon here. And so as I tap this area, I can actually get it to go up and down. And so notice that it by default just displays the location of where this particular image is coming from. And the same sort of UI is available on my other two platforms. And so if we set our Android project as our start up and we run this. And so here we can see our apps running on Android, and instead of little arrows, I can just simply take my mouse and slide, but my up and down still works, right? And actually it's anywhere in here you can tap and it will go up and down, not just the arrow. Obviously touch, you have to expand your range of what you can actually tap in order to make it go up and down. So this whole area is actually the tappable surface, but the arrow just sort of indicates that, hey, we can slide this up by touching here. So let's look at some of the commonalities here. So again, if I go back to my WPF app and I open up the XAML file here, you can see that it uses a dock panel, has a border around a text block for the title, and then it has a status bar at the bottom. And then here you can see here's our actual list of vacations inside of a list box with a group style, as well as a data template to display the actual image along with all the text block. And it's just got a lot of XAML, and it's all based on WPF. So you can see dock panels and stack panels and text blocks and things like that. And then it's got the actual details view, which is just a user control. On our mobile side, if I go look at the main page here, you're going to see it looks very similar. I have a grid, I have some resources in the grid with a style for my label. Notice that in our grid resources, if you're familiar with WPF, this is very similar. I can put all my styles inside here. The only difference is I have to declare the resource dictionary. And so unlike WPF, where you just start throwing styles and there's an implicit resource dictionary that's been created for you, you have to actually declare the resource dictionary here as part of the resources. And then I've got my row definitions with a star sized height and an auto sized height. That's all exactly the same as other XAML frameworks. And then I'm defining my carousel view. So this is a unique control to Xamarin.Forms, and it uses data binding. And so notice it has an item source that's bound to that same all vacations that we use here. And so in the list box, notice we're binding to all vacations right there. We're binding to the same all vacations here, and our item is bound to selected vacation. So the actual main view model that's driving all this is identical between these two projects. We have a main view model here that's actually got our list of all vacations and our selected vacation, and it raises property change notifications in order to say that things are changing. That's all shared code between the WPF and all of our mobile projects. Then I define a data template that has our image in it, and then I have the frame that moves up and down. So this is the animated frame. Now that animation, unfortunately, we don't have any way to actually describe that in XAML today, at least not for Xamarin.Forms. And so the way that that's actually set up here is in the main page XAML.cs, when you tap on that frame, I'm running a little bit of code in order to actually run those animations. And so you see we have some unique APIs here to animate and rotate and fade those elements. And so those are animation APIs that are built into Xamarin.Forms to be able to do the work that I'm trying to do here. And it's all driven off of this one single little method that's in my code behind. So this is unique to Xamarin.Forms, but the actual data storage and the representation of that data, where it's being loaded from, and all of that code that's part of that is all actually contained in our common assembly. And then it's shared across all of our actual platform-specific projects. So our UWP, our iOS and Android, as well as, of course, the WPF app. So let's switch back to the slides. For this final part of the session, I want to impart some practical tips on engaging the mobile development experience. These are things I learned the hard way, which I hope will be lessons that you can take with you. First, embrace minimalism. Mobile apps aren't desktop apps. On the desktop, we have tons of resources, and so most desktop apps do a lot of things for you. When shifting to the mobile arena, consider what the core functionality of the app should be and focus on that. Each screen in the app should be devoted to a single thing, with navigation provided to get to other core features you need. Here's an example. On the desktop, my mail application has lots of screen real estate, so we show folders, messages, and a full message thread all in one window. We also have a toolbar with common functions and a search bar to find and filter my messages. When we translate that experience to mobile, we define the core tasks, reading messages. So we reduce the window to a search bar and the messages contained in a specific folder. Context menus are still provided, but utilize swipe gestures or long press gestures to activate. Notice that we provide a preview of the message, but require that you tap on the message to actually view the entire contents. And at the bottom, we provide the most common tasks, new message, and a folder view to switch folders. We can also utilize orientation to change our features. For example, if I rotate the device horizontally, I can then display the message list and the full message thread for the selected message. Notice I also then have room to expand the message options, so I can do quick actions right here on the same screen. This sort of feature focus reduction is very common in the mobile world. I encourage you to look at other apps which have desktop parallels, particularly from Google, Apple, and Microsoft, to see how they transition to mobile in this regard. The second piece of advice is to embrace the platform. Each mobile platform has a unique way of doing things. Users expect their apps to behave in consistent ways, and so when you deviate from the norm, you should have a very good reason, and then sleep on it before actually doing it. Here's an example. The navigation paradigms for each platform are different. On Android and UWP, it's common to use hamburger menus located at the top. On iOS, it's far more common to use tabs. Always prefer the standard navigation system used by each platform. Remember that UWP and Android have back buttons on the device, and iOS supports a swipe off the edge gesture to go back. The app shown here is a Xamarin.Forms application, but notice that it adapts the proper design based on the platform. This is ideal because it's what users expect. In fact, each vendor goes to great lengths to document the expected user experience. Android publishes the material design specification with its flat shadowed designs with floating buttons. Apple has the human interface guidelines, which provide details for every one of their platforms from macOS to Apple TV. And Microsoft has the Fluent design language, which is an extension of their Metro design language created for Windows 8. Read these specifications. Examine their built-in apps. These are the standards you want to employ so your app looks and feels natural on the platform. Number 3, embrace touch. This might seem like a silly thing to say, but think hard about how people interact with your UI. Mobile devices are touch-based, and fingers are much bigger and less precise than a mouse. Make sure your interactive visual elements are large and not spaced too closely together. Think about how users hold the device while they interact with your application. Can they get to all of your features easily one-handed? This is important because a 2013 Stephen Huber study documented how people hold their devices, and almost half of them tend to use it one-handed. If your app requires daddy long leg fingers to reach core features, then you're going to have a usability problem. Mobile devices have some unique challenges which you just don't find in the desktop world. Embrace those differences. For example, it's common to have your network connection just disappear while you're trying to utilize it. Having robust algorithms to retry data operations and offline caches of critical data is mandatory in the mobile world. Your app also doesn't have the CPU or memory resources that your desktop apps are used to. You need to consider all the low-end devices people might run your app on and compensate by only keeping what you need in memory and offloading CPU-intensive algorithms to external web services where possible. Users will use your application in unexpected ways. If it doesn't respond immediately, they might tap or swipe things again and again, so disabling visual elements and providing them some feedback that your app is doing something is important. And your app has to be robust. Unlike the desktop, where apps are open and closed all the time, or where an application crash is generally a minor annoyance and the user just restarts the app, mobile apps are expected to be rock solid. They also don't have complete freedom. Typically, the only time they're given CPU is when they're in the foreground. Switching away from your mobile app will often suspend the application with a few special exceptions. Knowing these rules and exceptions is important to building a robust, high-quality application. That brings me to my final piece of advice. Always test on real devices. Simulators are wonderful. They're quick and often easy to test with, but they don't exhibit the same performance or complete behavior of a real device. There are a lot of touch gestures you can't completely replicate on simulated devices. Hardware buttons and on-screen keyboards might behave differently, and most devices support physical interactions to do things such as take screenshots. Make sure you test your app on the types of devices that you expect your users to have. As developers, we often have high-end hardware that our apps run great on, and then it gets installed on real user devices and the performance metrics are quite different. So test on all the supported variations that you expect your app to run on. To help with that, consider trying out Visual Studio Mobile Center. Mobile Center covers the entire application DevOps lifecycle from end to end with deep functionality in each area. One of those areas is Test Cloud, which is an automated testing platform I mentioned earlier. Recall that it allows you to run your application on real devices with a testing script that you build to run it through its paces. Test Cloud will execute that script on the devices you select and generate a full report on what worked and, more importantly, what didn't. That way, you don't have to invest in every possible variation of device. You can use our system to do that for you. Mobile Center is currently in preview. You can sign up today at mobile.azure.com and try it out for yourself. Well, we've reached the end of our time this morning. I hope I've given you some ideas on how to get started going from the desktop to mobile world with Xamarin. I want to remind you again about our excellent training at Xamarin University. We've got all kinds of content. A lot of it's free, but we also have a subscription service where you can get trained by Xamarin experts who have been building apps for years. We've got over 80 classes on a variety of topics to make sure you get the information you need, and subscriptions start at just over $83 a month. And you can use the same subscription you use for Azure services or for your Visual Studio MSDN subscription. Finally, here are some additional resources and links that you might be interested in. We'll be posting a recording of this webinar, and the slides and demos I did in the session are in the GitHub repository listed here. Make sure to check out the slides in particular. There are some things in there which I didn't have time to get to today. All right, I hope this has been helpful to everybody. Thank you so much for attending this webinar with me today. We're going to stick around and make sure everyone gets their questions answered, so I'll end here, but feel free to engage with our online experts in the chat window. Thanks everyone, and have a great day.